Hello friends. In my last video I showed you that my chatbot has now got a memory added and it can easily retain the previous conversation that I had with the chatbot. But while doing that, we saw that each time it is recalling the conversation that we had, which might not be needed because the output was getting very cluttered. So for that reason, in this particular program, I have made a good number of changes. Like for example, I will put forward a word called /history. Then only it will show me all the previous conversation that I had. If I have /clear, whatever conversation that I had which it was retaining will be completely removed, and if I go for /exit, the program simply terminates. Okay, so good number of conditions we have added. So let me see one by one all what is there in this program, right? Okay, let's run the code first. As I do that, my environment will be activated. Yes, the environment got activated. As you can see, it's got activated. So it is asking me to enter a question. What I will be doing is that, let me explain the initial part one more time. I'm making use of requests. Why I'm using request? Because Ollama is running as an HTTP API in this particular route, that is http:/localhost 11434 is the port number, followed by /API/chat. So this is the URL that Ollama is using. So to reach to this particular URL, we need the request package. I'm using the model called Llama 3:latest. That's the model which I'm using. Okay, great. And here exactly this message will be printed out, like what you can see right over here. And then I created a prompt which you have seen in my previous couple of videos as well. But in this video I would like to add a couple of more points. That is, well, this is not just a dictionary, but this is system prompt. And what this prompt determines, it determines the behavior, the personality, the rule and the constraint that the system must maintain. You can also say this to be like a role prompting. Okay, that is also can be stated because you have mentioned the role over here. What is your role? Your role as a system, you have to help me. You are going to help. And you also have mentioned over here the design, that it should be just one single paragraph and a constraint of size 50 words. So the role as well as the behavior of your chat you have mentioned. So usually in the prompt engineering we call it as a system prompt, right? Okay, great. And then what happens? This is where things starts getting changed. I created a list, but if you notice one thing, this is system prompt, which is a dictionary. I gone for .copy and wrapped it within third bracket because I want this message to be a list. Why? Because Ollama would process in the form of list only. Now what is this particular .copy function doing? Let me tell you that. Suppose I put an example over here that is without copy. So I wrote over here system prompt as a dictionary and it has got a role as system, right? And then it created another list. So this was dictionary, created a list of system prompt like what I did right over here, isn't it? Now what happened? Since you are making a copy from the system prompt inside the message list, both will point to the same location. Hence, if I say message and this is at the 0th index, which has got a key called role, and I've put the word assistant, you know what happens? You do this with the help of message list, but actually the system prompt, which is just a dictionary whose reference message was holding, that get changed. So your system will no longer be system, rather the modified version is assistant that is going to be printed out. So that means the system prompt gets replaced by assistant. It's all because you don't have .copy function. And what will happen in context to if I use a .copy? Well, in that case, what happened? I create a dictionary right over here, great, and I create a list where I pass the dictionary in a copied format inside this list. Now this list and the system prompt, they are not the same. They are totally different. Hence, if I reach message and it's a list, so at 0th index, I have a key called role, I can easily change it to assistant. In that case, what happened? If I print system prompt, it still retains system and not assistant. That's where the major thing implementation comes in picture. So for that reason, .copy function is really handy to be used. Okay. This also happens behind the scene because this particular list is going to hold the data in the form of a list of objects. So now we come to the while loop, which is true and it's infinite, and it is asking me to enter the message what I would like to ask to Llama 3 via Ollama. So it's asking. Again, I will go with the same question like what is Python? Okay. As I hit the enter, it will go to this particular string variable called user input. It will go and check that this string, is it /exit? No, it's not. Had that been so, it would have terminated from the while loop, but it won't do that, right? So it will come over here. Is it history? No, it's not history. Is it clear? No, it's not even clear also. Great. So what it does is, I already got this particular list. Inside the list, what it's going to do? It's going to append. So this is what I was saying. I'm changing the role. So initial role was what? Initial role was system. But since this message is a separate copy of list, I can easily change the role. And I would like to add over here user. Great. The input which I have given over here, I will be reaching this particular content. Remember this content, that also I'm going to change with the user input. Hence, this message is a new copy and the system prompt remain intact. Isn't it great? That's the reason why .copy was so crucial. If this copy was not there, then it will always work on the system prompt and the system prompt will be removed. But this is not what we can allow it, because system prompt actually defines the behavior of your AI, what type of constraint you are putting, what rules you have set, and how exactly the data to be put forward. Everything's inside this system prompt, so you cannot change it, right? This is your base nature. You know, every individual has got a base nature, which I believe it's not easily changeable, right? Once in your lifetime, maybe you will perform alteration. Every day we get updated, but our base character will remain intact in our subconscious mind as well. Okay, let's get back to the topic. So message gets changed, and now we are creating the payload that I want to forward. The Llama would forward it to the Llama 3, and it would be in the form of a dictionary. As you can see over here, I write the model name, that is Llama 3 colon letters, the message which is the complete form of a list, and that's very important. And in the list we have got role and content, as you can see right over here. And finally, I want that the data should be in the form of a stream. That means it will come part by part. Text tokenization is going to happen over here. So I created this payload, and now is the high time my Python code should give a call to the Ollama HTTP API running at localhost port number 11434. And the endpoint is /API/chat, and that's what we give a call right over here. And once we have done that, now is the time to wait, because in this I mentioned the location where my Ollama server exists, what message I have forwarded right over here, and the stream it should be a text tokenization. So we have to wait. The response gets figured out, and inside the response the data will come, and this is all happening inside this while loop. Now we created a string variable because I have to store the data as well, because Llama 3 will send the data in the form of a text. So it would say that Python is a, so each words are going to come individually. So for that reason I need to put them as a collective, so I have this particular string variable as a whole, but I will be displaying them in the string fashion, and the entire answer that comes from Llama 3 I will save it inside my message so that I can show you what was the response for the given question. Okay, so now we are inside the loop, and this is a very interesting loop. It is called iterate_line. So the iterator is going to wait because your Ollama HTTP endpoint is active, it's open. So one by one the word will come over here and it will check if the word is there. Yes, it is, but the initial word will be in the form of JSON. It need to be converted to Python object, and that would be in the form of a dictionary. I want to show you what kind of response will come from Ollama. See over here, this is the response. It would be like this: a dictionary is there, and it will make use of the, I would like to tell you one thing over here, that is a Llama 3 is just sending you the text only, but this entire dictionary has been created by Ollama. So over here we have got the key called model, where it will write the model name as a timestamp at what time this particular data was received. I mean, like the sentence will receive. Okay, let me hit the enter over here, then it will be easy for you to understand it, and we will see that it's taking a time because server is getting activated, and I have stopped it. And now see, this is what the stream is. So Llama is just sending a single word, like Python came in the first instance, is came in the second instance. That means this particular chunk, this particular dictionary will be recreated each time. Yes, you rightly heard, it recreated each time. So it will have a model mentioned over here, it will have the timestamp when this particular text was received, and the message will be in the form of a dictionary. Over there the role is assistant, because Llama 3 is providing the answer, so it's considered as an assistant. And look over here, the content is Python. Why did I write Python? Because this is the first word that is Python. And why done is false? Because more words are going to come, so for that reason this is going to be false. So this kind of chunk object, I mean dictionary, will be created for each of this word. Like for Python, it got created is got created it's got created high level. So that means all the word that you find in the complete paragraph, this kind of chunk will be created for each one of them. So number of word equals number of chunk. Got it? The last chunk that comes after which the string will not carry forward anything, HTTP Ollama will stop sending. There where the done will be true, that means it means that it's actually over. And that's how the iterator_line get to know that how long it need to retain inside this particular loop, and once it receives the done true, it will terminate, right? And that's how we get to see this words that got printed. So this is how the line is going to be printed. This is how the conversion of JSON string to Python object has been created. And look over here, inside this chunk what we have a key called message. So it's checking, do we have a key called message? The message will come only when the response will come from Llama 3. So here we are checking whether the message key is there or not. The answer is yes, it's there. Great. Now what you do, you have to retrieve the data. So what you do is you start the location from chunk. Here it is. Inside chunk you have a message, you wrote that, and inside message you have a content, you wrote that. That means the leveling from 1 to 2 and then to 3 has been done, and we got the entire content, that is just the word Python, and that got printed, and that's what got printed with a space in between. Right, it got printed one after the other, it gets printed, and this process continues till all the last characters that is alike comes in, and the done is now true, and the process ends. Right, so while doing that we are storing individual words into this particular string, and finally what we are doing, we're again going to append the list which I've created over here, so that once I run it I can get the history back and I can see what was the answer that came. So over here I am just adding the response that has came on basis of the last question. Remember, this is not a prompt, this is just a storage of information that came from Llama 3 was given, and Ollama converted to object. It was just going to store that information, so that when I will go for /history, and well, I will do that. Before that, let me put one more question, that what is the difference between 11 minus 22? Very stupid question, isn't it? What is the difference between 11 minus 22? Let's see what the answer is coming. Yes, exactly. what is the difference between 11 minus 22? It came up with 11. So this is also the response. So that means this response need to be stored inside this message, and that has been done. Great, right? Now I would fire, it's waiting for my response, so I want to fire the response that is called history. And once I do that, you will get to see something amazing. So let me close all this part, and I have done with this part. Now I will come up to the history part now. So as I type history, what happens? Let me do that, and you get to see what happens. So slash history, history, right? I hit the enter. The user prompt is checking, is it history? Yes. So it will generate certain display messages, that is the conversion history it has generated. Great. And now see, inside this message we have got the system which was generated for the first time. The system was there, so it is checking the role is system. Here's the role is system. And what was the message that I gave over here? You are a helpful assistant and answer briefly in one paragraph with almost 50 words. That's what you see. If you notice over here, I have put a pair of parentheses, and this pair of parentheses is actually a string literal concatenation, because I'm going for multiple lines, but at the end it will display just a single line. Okay, it might seems like a tuple, but over here we don't have any comma. So it's not a tuple, rather it's a string literal concatenation, and it will generate one statement, as you can see right over here. So it checked that inside this particular message there's a role called system. Yes, it's there. That got displayed separately. Now what you're checking is that do we have a role called user, right? The role called user is there, because after you send this entire thing, as you saw over here, when you are generating this, ultimately the response came over here. So yeah, let me show you over here. See the role append user, right? So let me close this. So this was the prompt that was, the question that was provided to Llama via Ollama. So that was the user. So that's the reason it says user. Yes, and user has a question called what is Python, which is asked for the first time, and this is the reason why I need this particular append, so that it can store the answer. And that's where assistant comes in picture, right? And as you can see, the role is assistant. Okay, so again it goes up and it prints the next. Again it prints. See over the assistant with this particular answer is coming in picture, right? So as you can see, this entire formatting has been done, and is all been stored inside this message content. So if I come back to this again, see, this is where the thing is coming, the role and the content, the role and the content, all this coming from this message list, right, which we have generated. So again it will go up and it will print the next one, what was my next question and what is the corresponding answer, and after that it gets, and nothing is there, so it get back to again the input part for waiting for the next question to come up with. So what I will do is that let me fire one more question, and then I will go for the clear option, right? I know the video is becoming a little lengthy, but it's worth watching. So what what's the product, I'm writing a short one, product of 4 into 3. What is the product of 4 into 3? So let's see what it does, and the product of 4 into 3 is 12. Perfect. So the third question also came up, so I will go for a slash history once again, and as I do that, what you get to see is you get all the chance questions. See, you got all the questions. First question their answer, second question their answer, and third question their answer. And now I will go with the option called clear. So once I go for clear, actually it took a good amount of time for me to do all this thing. What clear is doing, it's just removing, it's creating again a copy of the system prompt. That means it will imagine the system prompt, the message list is just like this. It has got the dictionary, it has got a dictionary inside the list, right? So if you go for a copy again, you are creating a new message list. In that case, the old message list is completely discarded, because you are creating a new copy of the message list. That means inside the memory there will be only one message list. In fact, initially I was thinking that how can I remove all these things, and it actually took me a good amount of time. I couldn't figure out easily how to remove this, because all that I did was last night and it was quite late, so maybe my brain was not working properly. But finally I understood that why I don't use this one. Yeah, because if I do use this one, it will recreate the message and the old message will be completely lost. How simple it is, right? Yes. So let me go and write over here slash clear. So once I do that, slash clear, and if I do that, clear conversation, And now if I go for /history, you will find nothing left in the conversation. See, history will be, see, nothing is there, it's showing just empty. Okay, and again it's just showing only the system prompt which I've given. So if I write what is the remainder of 3 divided by 2, so what is the remainder of 3 divided by 2? It's just 1. So if I now go for history, I will just see only this question /history. Right, and all the previous conversation has been completely reset. Finally, I come to an end of this video, and this is really was a quite interesting video for me, and it took a good amount of time, and I hope that you can figure out that so many internal logic that was happening. And as I said always, that this is something I'm doing from the scratch. I'm not using LangChain, because before I want to get into LangChain, I want to understand the architecture of a system prompt, a user prompt, and how exactly Ollama works with Llama 3 for the given model Llama 3 : letters. Okay, that's all from this video presentation. I'm still waiting to connect this thing into Django, and that's going to be a really remarkable achievement. Okay, see you soon. Bye bye, take care.